Okay, the first two videos, part one and part two. This is part three, integrals, part three, double integrals, part three. We saw how to find the area by doing first integral of f of x dx, then integral to dy, and or dy then dx the same, because it's dimensions, right? If we multiply the length, the width, the height, it will be the same. So exactly, let me do it on the same figure. If we try to do, let me do it in red or in blue. If we try to have first a small square over here, a small square over here, or a small rectangle, let's say this small rectangle, what are the dimensions of this rectangle? The length of this rectangle, right? The length of this rectangle and the width of this rectangle are simply dx and dy, right? Small change, because small change in x and small change in y. If we find the area of this small square or rectangle, it will be length times width, right? So it will be dx dy, dx dy, and we still need to multiply with the height of this, right? We still need to multiply with the height of this rectangle shape. It will be a rectangular prism, right? Something like that. This height is simply the z-axis, and the z-axis is a function in terms of x and y. So we multiply f of xy. Length times width times height will give me the volume. If we find the volume, but not now, the volume of this, right? If we want to find the volume of the whole solid body, if we want to find the volume of the whole solid body, it will give me what? It will give me simply, I will have all these parts beside each other in both directions, either the x or dy direction, right? Either the y direction or the x direction. This means it will be integral, right? If we start with, let me try to do it here. If we start with, right, the x first, this means it's integral of f of x y, f of xy. Let me just, my phone is ringing.